I hear you. That is a lot of cubes to let loose in the classroom, Anita. Surely there's another way. Well, of course there is. Let us now take our journey to a teacher-centred whole class lesson starter context using just a 3x5 array dot card in a Year 4-5 classroom, perhaps at a week where we're commencing to teach fractions. To connect concepts for all children and plug gaps in their learning at the same time, I like to use the following teaching sequence. And with Year 4-5, it goes a little like this. Pretend you're back in kindergarten, Year 4-5. How would you have counted these 15 dots? By ones, Miss Chin. And you think to yourself, yep, and some of you still do. I then ask students to write a number sentence which describes this counting. Year 4-5, then you're in Year 1, where you learnt that there were 5 dots in the first horizontal row. How would you have counted the 15 dots then? By 5s, miss. 5, 10, 15. I then ask the children to write a number sentence which describes this counting using addition. Next, I ask them to prove to me how they know that 5 plus 5 plus 5 equals 15. After a little hesitation from students, I then visually scaffold for them by saying, Year 4-5, if you're not sure what I'm asking, here's my hint. There were 15 people seated in the cinema, and after the front row stood up to leave, there were only 10. Then the second row stood up to leave, so only 5 people were in the cinema. Then the last row stood up and left, so there were no people in the cinema. Students are then usually able to write a number sentence to describe this using subtraction. In other words, we use subtraction to prove addition, which is our algebraic thinking. I then explained to Year 4-5, all right, you then made it to Year 3, where you learn about multiplication. How would you have counted the 15 dots then? To which they reply, 3 5s are 15, and they write 3 multiplied by 5 equals 15 symbolically. However, we need to ensure that they have a conceptual understanding of multiplication as being repeated addition, that they are not just regurgitating a rote-learnt fact. This is called multiplicative thinking. Furthermore, I now like to move to algebraic thinking by asking children, what multiplication fact does this represent? And if I spin, turn, or rotate at 90 degrees, what multiplication fact does it now represent? Which of course is 5 3s. This is called the commutative property. In other words, fact-wise, it's all 15, but pictorially, it's different. I then ask children to record their thinking symbolically. Next in our sequence, of course, is division, where I ask, if I have 15 dots and I share them equally into 3 horizontal rows, what division sentence could we write? Also, if I share 15 among 5, how many dots are in each row? This is always interesting to observe what children write, as some students incorrectly combine division sentences, which highlights their misunderstandings of the equal sign, which means is the same as. Finally, I'll say Year 4-5, now that we are learning about fractions this week, if you focus on the first horizontal row as being part of the total amount, please write a sentence using fractional language to describe what you see. Firstly in words, and then symbolically using fraction notation. Here's a nice assessment I did. This is a work sample from our Year 4 student when shown a 3x5 dot array and asked to write about what do you see. Not only can we see a connection of concepts to prior learning, leading to factors, we can also see evidence of extended learning by the use of improper fractions. And you just thought 3 5s were 15 and you were done. So, by asking an open-ended question, we've given this student an opportunity to demonstrate not only what she knows, but also what she can do with what she knows. How wonderful is this? Yes, you can start every lesson with children seated in an array. If you'd like to see how I actually do this as part of a lesson starter, then be sure to watch the demonstration lesson video. I know what you're thinking. What if you don't have a friendly number of children for your lesson? That's okay. Enter stage left, the remainder. Now if I was to ask you, what do you see? You may want to hit the pause button and challenge yourself to write down as many number sentences as you can to describe how you know there are 23 children. Let's see how you went. I know there are 23 children because I counted them. 5, 10, 15, 20, 21, 22, 23. Or did you write, because there's 5 in each row, and then there are 3 more standing? Perhaps you wrote, there's 3 standing next to Anita, and there's 4 rows of 5 children seated on the floor. Altogether, that makes 23. Or perhaps you were thinking, well, Anita tried to sit the children in 4 equal rows, and they sat down with 5 in each row, but then there were 3 remaining, so they had to stand next to her. And finally, did you write down the good old high school textbook question, which is, simplify 23 over 4, or better still, express 23 over 4 as a mixed numeral. So, in summary, we've used an array model as a visual model to connect concepts for all students, to plug gaps in prior learning, to extend multiplication and division concepts to fractions, and to enrich students' understanding of mathematical language in both written and verbal forms. This now completes our journey together from F to 6, and it's now up to you to decide which aspects you'll trial back in your classroom on your adventure. Be sure to watch the subsequent videos where you can see these ideas in action with children and to explore additional teaching and learning activities. So, safe travels, keep your concrete materials in check, and I look forward to hearing about your journey in the forum post. Good luck!